All right, so this is the Algebra 2 final review. And I'm going to try to go through this as quickly as I can. Again, there is more information on here than is actually on the final. I think the final only has 19 questions, and this has about 26. So some of this will get cut, but you have a list, 3, 8, 13, 18. The list is clearly going up by 5 each time. That's an addition of 5. If it's addition or subtraction, I typically used a sub n equals the gap times n plus any compensation, or the amount you'd have to adjust by. So that would be a sub n equals, our gap is a positive 5n. Now the issue here is that if I plug 1 in for n, I'm supposed to get 3, because that's the first term. But if I put 1 in there right now, I get a 5. So to make the 5 become a 3, I will minus 2. Now it's always a good idea to check. So if I plug 3 in there, for instance, 5 times 3 is 15, but minus 2 is 13, which is the third term. So this is the equation. There is another way using the formula a sub n equals d times n minus 1. Oh, I'm missing something here. It's a sub 1 plus. There you go. A sub 1 plus d times n minus 1. That will work. You just have to, you've got to work through that same formula, do some simplifying, it'll come out the same. Question number 2 is another sequence of data, 256, comma 64, comma 16, comma 4. Here we see the numbers are decreasing, but it's not by addition or subtraction. It looks like it's by multiplication or division. When we do multiplication or division, we always focus on finding r, which is the multiplier. So because these are getting smaller, I'm thinking of a fraction less than 1. For example, 64 divided by 4 is 16. 16 divided by 4 is 4. So if r is 1/4, that means to divide by 4. Okay? So think about times 1/4, times 1/4. Not an exponent, but just multiplication. And the formula for a geometric sequence like this is a sub n equals a sub 1 times r to the n minus 1. And so our formula would simply be the first term, which is 256, times the value we keep multiplying by, which is 1/4, to the n minus 1. And that's our formula. There's really not a second way. That is the way to build those. If we go on and look at question number 3, we have a sum of n equals 3 to 8 of 2n minus 5. There are two ways basically to do this. The first option is to plug 3 in, then 4, then 5, then 6, then 7, then 8. You'll get those 6 answers. For instance, 3 plugged in is 6 minus 5 is 1. So the first term here would be 1, and then I plug 4 in and get 3, and I keep adding up these terms until I get to the 8th term. I add all those up and get a final answer. But I can also use my calculator. So I'm going to show you where that's at. If you're using a TI-84, this will work well. We press the math button. You can see how I touch it and that little icon blinks. So I'll show you where I just pushed math. And then I'm going to scroll up. I can scroll down, but my goal is to eventually get to where it says summation, which is option 0. If I press enter, now I can put in x. I know the equation says n, but you can use x interchangeably with it. X equals 3, I arrow up to get 8. And then these parentheses that are there are not mine to use, so I have to live within those. 2 x minus 5, I press enter, I get 36. So this whole thing would equal 36. Okay, so question number 4, very similar in the way that we do question number 4. It's a summation, but it's to infinity, which means that we have to look for some specific things. First thing we need to acknowledge is that it's exponential, or that it's geometric. Because it is the multiplication variety, as evidenced by the exponent, it's possible to do an infinite sum. The other thing we have to look at is that the number in the parentheses has to be less than 1. 2/3 is less than 1, so this is doable. If that value did happen to be greater than 1, there is no sum. We can't physically add it. It's only because that value is less than 1, meaning that the numbers shrink. Okay? Now, there is a formula we're going to use to do an infinite geometric series, or an infinite sum. And the rule is that we take a sub 1, which is the first term, and divide it by 1 minus r. Now, r is just what's in the parentheses. So for sure, we're going to have something over 1 minus 2/3. That one's the easy part. A sub 1 sometimes turns out to be this number out in front, but it's actually not a guarantee that it's going to happen. The rule for finding a sub 1 is always to take the value here in the in the beginning of the summation and plug it in. So in this case, it's 2 times 2/3 to the 5th. So I'm going to go ahead and grab my calculator to calculate that. 2 times parentheses 2 over 3, close parentheses, raised to the 5th. And I get 0.2634. 0.2634. Now I'm not actually going to use 0.2634. I'm going to use the number that's in my calculator. But I'm going to get that 0.2634 over 1 minus 2/3 is really just 1/3. I'm going to put some parentheses around that so I can use my calculator. So I'm going to take the number that I have and I'm going to divide it by parentheses 1 over 3. Now technically this is just a flippant times. I could just multiply by 3, but I'm just being a little cautious about the way I type it all out. It's 0.7901. Now, to be honest, I'm pretty happy with that, but it's always a good idea to see, is there a fraction equivalent that isn't too bad? So I would take the 0.7901, 0.7901, but what I would prefer, because it's nicer and cleaner and there's no rounding, is 64 over 81. Okay? Either one of those would have been acceptable to question number 4. All right, number 5. We get a graph, number 5 and 6. Y equals 2x minus 4 over x minus 3. And I ask for the domain. And in these, the domain is always restricted against certain values. The issue is you're not allowed to divide by 0, so whatever would make the denominator 0 is what we're going to restrict. And so if x happened to be 3, the denominator would equal 0. So x is not allowed to be 3. That's the only real restriction. And the nice thing about that is that's also where we put the vertical asymptote. So if I come out to 3, there needs to be a visual break in the graph there. The rest of this I'm going to do just straight into my calculator. Go to y equals. Let's turn that off. I don't want that on. I'm going to start with parentheses 2x minus 4, close parentheses. It's really important that you group the top and bottom separate from each other so that you don't have a bad graph when you go to the calculator. And I'm going to change my view because I've been messing with it. The nice thing is your guys' calculators will have been reset, and so you won't have some of these issues. And so there's my graph. I can see that here at around 3, if you can kind of see where the cursor is, right there at 3, there's a break in the graph. And so there's a graph to the left and a graph to the right. Now, it is nice to find the horizontal asymptote, which is this horizontal line, if you will, that goes across. The nice thing is, when you have a balanced equation, meaning you have x to the first over x to the first, you just need to look at the leading coefficients, which is 2 over 1. So up here at 2, I'm going to put that dotted line in. Okay. If it's bottom heavy, then it's always at 0. So this is really just the only other case, is when we have this leading coefficient stuff, if the exponents match. If the exponents were different, it would have to be bottom heavy. Top heavy is something we study in pre-calculus. So if I think back to that graph, it was down here following this, and up here following this. Staying around those boundaries, but not actually touching them. As a side note, if the top ever equals 0, and you're able to find that for me, I'm considering giving you some extra credit there. So what would make the top 0? Well, if you added 4 and divided by 2, x at 2, so I'm going to make a really clear point right at 2. Might even say crosses at 2, at x equals 2. It's not crucial to the graph, but deep down that's an important value. And if you can get in the habit of indicating that information, then that's a good thing. That's a good thing to have. When you go into pre-calculus or college algebra, there's going to be more requested of you, and that's one of those things that they can ask for. Okay? If we look at question number 6 right next to it, y equals x minus 3 over x squared minus 2x minus 8. And on that note, while I'm talking about where it crosses, okay, right now, if I look at the top would be at x equals 3, would make it 0, okay? And so if I went over to 3, I'm expecting it to cross at 3. I don't know if it's going down or going up, but I know that's going to happen. The denominator is x squared in comparison to x to the first, so there will be a horizontal boundary right there at 0. Now, I still cross that horizontal boundary at 3 because the graph's telling me to. If you didn't cross it, it's not going to be marked wrong. I just won't give you that, extra credit if it's available. The next thing I need to do is find the asymptotes. Well, I need to know what makes the denominator 0 because that's my domain restriction. Okay? What can x not be? Well, this would be x and x. The factors of 8 that subtract to 2, right, would be 4 and 2, a negative 4 and a plus 2. Meaning that the asymptotes, because I want this to not be 0, would be at negative 2 and over here at positive 4. Meaning that in my domain, x cannot be negative 2 or positive 4. I could try to piece together the rest of this graph on my own, but I prefer to just type it in the calculator. And so I'm going to have my x minus 3 over, and I'm going to go to the original. I'm not going to do the x minus 4, x plus 2 thing. It's easier to just do x squared minus 2x minus 8, close parentheses, graph. We should see 3 distinct pieces. Okay, so this is really important that you understand right here, if you can follow, okay? So first off, there's a graph coming downward. Then it picks up here. This is what gets a lot of people into trouble. It's coming along, it blends into the axis, and then dips down. But that's one continuous piece. And then right here, I have this going along the edge. You remember how I said it crossed at 3? That's this guy right here. So let's go back and put that together. So in the middle, it had this sort of zigzag shape, almost like a tangent curve, if you remember what those look like. And then of course it was down here, and of course it was up over here. And that right there would be maybe a bonus point if we can indicate where that exists. If you didn't know exactly where it happened, it wouldn't kill you to just keep drawing, but it does give you some extra validity to saying, I know what I'm doing, if you're able to finish that. 7 and 8 are very similar. 7 has x squared minus x minus 6 over x squared minus 4 times x squared plus 5x minus 14 over x squared plus 4x minus 21. You see x squared, the first thing you should try to do is factor. So I'm going to factor the top and bottom of each of these as best I can and see if something cool and magical happens along the way. I know that x squared splits as x and x. What are the factors of 6 that subtract to 1? That would be 3 and 2. To get a negative 1x, I'll need a negative 3 and a positive 2 when I add. Down on the bottom, this is a special factor pattern. It's called the difference of squares. So it's x plus 2, x minus 2. It's the square root of 4 that we're thinking about. Not half of 4, but the square root. So if it was a 9, we'd use 3. Up here, it's x and x. Factors of 14 that subtract to 5 would be 7 and 2. To get a positive 5, I'd have to have a positive 7 and a minus 2. And then last but not least, x and x, factors of 21 that subtract to 4, that's going to be 7 and 3. Because the 21's negative, signs are different. To get a positive 4, I'll need a plus 7 and a minus 3. Start looking for top to bottom cancellations, an x minus 3 and an x minus 3. X plus 2, x plus 2, x plus 7, x plus 7, x minus 2, x minus 2. I'm not suggesting this would happen again on the final. But if it did, if everything cancels, because we're canceling by division, any number divided by itself is 1. So our answer should come out to 1. Number 8 is very similar. It has one small difference. Oops. Woo, losing my touch here. Okay, number 8. It says x squared minus 16 over 3x plus 6. Make that a plus, all right? Divided by. Well, I don't like division of fractions. We've talked about this over and over again. We don't actually have a way of dividing by fractions, so I'm going to turn it into times, and I'm going to flip the second fraction. The original fraction had x squared plus 5x plus 4 on the top. So I'm writing it on the bottom because it's going to be upside down. And on the bottom, it originally had 6x plus 6, but now that's on top. All right. Still trying to factor. So over here on the left, that's a difference of squares. X plus 4, x minus 4. On bottom, there's not an x squared, so I can't do the two sets of parentheses. I'm going to have to do a GCF factor where you pull out the common term. In this case, it's 3. And if I think about pulling the 3 out of the two of those, it'd be x plus 2. Whew, that's funny. Times, over here, I notice the 6x plus 6 also has, it's looking for a pattern of some sort. There's no squares, so it's got to be a common term. Be x plus 1. Okay, on the bottom, two sets of parentheses again because of the x squared. X and x. Factors of 4 that add up to 5 would be 4 and 1. And because everything's plus, it'd be plus and plus. So the x plus 4 can cancel the x plus 4. There isn't an x minus 4 to cancel, but there is an x plus 1 and an x plus 1. So normally this is kind of where you just shove everything together, but I noticed that the 6 and the 3 can also reduce. So I'm going to change the 3 and the 6 to a 2 and a 1. That leaves me with 2 times x minus 4 over x plus 2. Now there's no simplification I can do from here, so I am done. Sometimes lots of stuff cancels, sometimes very little amounts of things cancel. All right, so now we're on to number 9 and 10. By the way, all of this so far has been chapter 12 and then followed by chapter 8 is kind of where we've been working. Number 9. Oof. See how long the board works with me. All right, we have x over x minus 3 equals negative 1 over x plus 1. Okay. Because we just have a fraction equal to a fraction, we can cross multiply. Okay. And so when we do, we're going to get x squared plus x. And that's because we're distributing into that denominator. X times x is x squared, x times 1 is x. It will equal, we're going to do the same thing here. Negative 1 times x is negative x. And a negative 1 times negative 3 is a positive 3. I see that there's an x squared in the problem, which means the only way to solve it is through setting it equal to 0 and working a quadratic. So I'm going to add x and subtract 3 from both sides so I can get it equal to 0. All right, so that's all gone. You get 0 on the right, x squared plus 2x minus 3. Now I can go to the quadratic formula as soon as I'd like to. I personally I don't really want to go that route if I don't have to, because it is a little more complicated. I think these parentheses and factoring have worked pretty well for me so far on this test, so I'm going to keep with that. X and x. What are the factors of 3 that subtract to 2? That'd be 3 and 1. To get a negative 3, they've got to have different signs. To get a positive 2 when I add, I'm going to go plus 2 minus 1. Well, that means that in order for this to equal 0, x would have to either be negative 3 or positive 1, based on making those parentheses 0. However, we have to compare our answers. When x is in the denominator, we're not allowed 0. Well, if I put 3 sorry, if I put negative 3 into the calculator, I'm okay here because negative 3 would be negative 6. And negative 3 plus 1 over here would be negative 2. Those are okay because they're not 0. However, one of my answers was 1. If I put 1 here or 1 here, I would get 2 on the right and negative 2 on the left. Also okay. So I get to keep both those answers. At first you might have thought we had to reject both of them, but keep in mind the answers negative 3 and 1 do not make the original problem have a denominator of 0. All right, last one for this half of the video, or this part of the video. Number 10 is x over x plus 1, okay, minus 4 over x equals negative 1 over x plus 1. Okay, because of the fact that it's not one fraction equal to one fraction, we cannot just cross multiply. And because of this negative right here, I really want to change that to a negative 4. Make it plus a minus. The reason why we want to change that is just so the distribution will happen on its own. I want to start by finding the LCD of this whole problem. So the LCD is going to be x times x plus 1. One of the things to remember here is you cannot change the denominators by addition and subtraction. It has to be multiplication only. So that x right there, it can't be turned into an x plus 1. Not possible. What we can do is we can multiply every single thing in the whole problem by the LCD. And if you think about distribution of the LCD through here, you cancel part of the LCD by the denominator. So if I look at the LCD and I look at this first fraction, the x plus 1 will cancel. The part that doesn't cancel is this x. So that still has to multiply, and x by x is x squared. When I distribute it to the next piece, this x is going to cancel, but the part that won't cancel is the x plus 1. So I have to distribute a negative 4 times x plus 1, which I'll do in just a minute. That's why that negative 4 is really important. A lot of people will leave the minus and forget to distribute. Now this equals, here when I distribute this last time, the negative 1 will be left, and the only piece that I haven't canceled would be this x, so negative 1x. So I'll distribute the negative 4 and get x squared minus 4x minus 4, equals negative x. So I'm going to add the x over to get 0 equals x squared minus 3x minus 4. Again, this is a place where I can either use the quadratic formula or I can try to factor. If I try to factor it out, I'm going to have x and x. Factors of 4 that subtract to 3 would be 4 and 1. Now this is important that we get the signs right. In order to have that negative 3, I'm going to need a negative 4 and a positive 1, meaning that x could equal 4 or negative 1. Again, I go back to the very beginning. If I put a negative 1 into that x right there, this denominator becomes 0, and I have a problem. So I have to reject the negative 1. I can keep the 4, because if you look at it closely, it's still a valid option for us. What I'm going to do right now is I'm going to jump over all of the trigonometry, and I'm going to go to the last 3 questions, 24, 25, and 26. We will come back to the trig on the second part of the video. So if we look at number 24, it says how many locker combinations can be made using 50 numbers if 3 numbers must be selected in order. Okay, and so if we look at just asking the question, is it a permutation, an NPR, or is it a combination, NCR? That's really the question that we have. We're going to pick 3 numbers off the combination lock and decide, how do we put them in. If the order matters, or what you're doing is order sensitive, then you have to use a permutation, which a locker combination is order sensitive. So I would say that I have 50 numbers, and I'm picking 3 of them in order to make my combination. Now it sounds weird because I'm saying combination, but it's not a combination, it's a permutation. That's one of the things that's kind of a structure issue in our normal language. Okay, is we use the word combination in place of permutation all the time. Well, I'm going to start with my 50. Then I'm going to go find the NPR button, which is in the probability, and it's the second one down, NPR, and I'm choosing 3. Gives me 117,600. So 117,600. Basically what I'm asking you to do on this question is know how to determine how many ways something can be done. Does the order matter? Does the order not matter? You know, how many objects do you have? How many are you choosing? Those are important things. Okay. Then if you look at 25, it's a data set of 13, 22, 18, 16, 13, 15, 18, 15, and 13. 1, 2, 3, 4, 5, 6, 7, 8, 9. I think that's right. 9 values, good. And we're being asked to find the mean, the median, the mode, the range, and the standard deviation. Now, the mode is the most common. I can look at this list. I see 13 show up 3 times, 15 and 18 are only twice. So I can say that the mode is 13 without doing any calculations. The rest of it I'm going to put into my calculator and work there. I always start with stat. I need to edit the data. You should have a cleared calculator before you start, but if there is something there, you just clear it out. My list started with 13, and then 22, and then 18, 16, 13, 15, 18, 15, and 13. And that's 9 values, so I'm pretty good there. Stat, I slide over to make a calculation. It's one variable, statistics. And I enter down to calculate. I get an average or mean of 15.89. 15.89. Go back to my calculator. Standard deviation, down it's that weird looking O, is 2.85. 2.85. The other 2 values I can find by scrolling down. The median is listed as 15. And the range is the biggest minus the lowest. Well, the max is 22. The min is 13. 22 minus 13 is 9. So the range here would be 9. And there is all the information you're being asked to find. Mean, median, mode, range, standard deviation. Last question on this part of the video. 26 is not going to be what 26 says, because we didn't get to that material in 11.3. But back in 10.3, we did talk about probability. And so I might ask you a question like, what's the probability of drawing a certain card out of a deck, given certain contexts or certain situations, okay? And so, for example, let me come up with a reasonable example. What's the probability, okay, of drawing 2 aces, okay, out of a deck? That's what you're being asked to find. 2 aces in a deck. You're going to be dealt 2 cards. What's the probability that both of them are aces? Okay, and so you'd say, okay, well, there are how many aces? Well, let me back that up. I want to change this on you in just a second. Let's change that. What's the probability, let's do something really straightforward, of drawing 3? Just a single 3. The probability of drawing a 3, okay, would be, for instance, there are 4 3s out of a deck of 52. Makes it 1 out of 13. That's an example. Another example might be a probability of getting a 3, and I might say something like, given that you already drew a 7 and a 5. Okay, so let's assume you already drew 2 cards out of the deck. Well, have you drawn a 3 yet? The answer is no. So there's still 4 cards to draw from to get that 3. But how many cards are still in the deck? Because you took a 7 and a 5 out, there wouldn't be 52 anymore. There would now be only 50. And that reduces to 2 out of 25. Slightly better chances of drawing a 3 than you had before. Just barely, but slightly. So that's the first half of the test, I guess first and the end. Hopefully that's enough to kind of get you started. We'll have the other half of the video posted tomorrow on Friday. Good luck, and I'll see you in class.